Welcome back to Talk Tensors, the show where we talk tensors and AI and machine learning research. And today we're diving into a paper that a listener actually sent our way. It's called Cognitive Bias Detection using Advanced Prompt Engineering, which is on its own, it's kind of catchy, right? But what really got us interested is how this paper is kind of flipping the script on how we usually think about AI and bias.
Yeah, I see what you mean.
You know, we're so used to hearing about, like, oh, AI is biased, AI is going to, make biased decisions and all that. But these researchers are saying, hold on, what if we use AI, these really powerful LLMs, to help us spot our own biases, the biases we humans put into our writing?
Right. I mean, for the longest time, a huge chunk of AI research, especially when it comes to ethics, has been about making sure that the AI systems themselves are fair and unbiased. Like, how do we build algorithms that don't, perpetuate societal biases, that kind of thing.
Right, exactly.
But this paper is asking a totally different question. It's like, okay, we've got these super powerful language models, right? They can understand and generate text like never before. So what if we use them to actually understand our own biases better?
It's a super interesting approach. I mean, think about it. Like, we all have biases. It's part of being human.
Oh, absolutely.
But we're often not even aware of them.
Right. They're kind of insidious like that.
Yeah, they're hidden.
Yeah.
And they can really mess with how we see the world and how we communicate with each other.
Totally. And that's, I think, what makes this paper so relevant. I mean, it's not just an academic exercise. It's about, helping us be more aware, more critical thinkers.
Absolutely.
Yeah.
And what I found really fascinating about this paper is their whole approach. They're saying that with the right kind of prompting, with the right instructions, we can train these LLMs to become like bias detectives, I guess you could say.
Yeah, exactly. Like, imagine giving an LLM a piece of text, whether it's a news article, a social media post, or even, an academic paper, and the LLM can say, hey, this piece of writing shows signs of confirmation bias, or there's some circular reasoning going on here.
Right. And the researchers, they actually did this. They ran experiments where they gave an LLM different kinds of text, and they found that with their carefully designed prompts, the LLM could actually pick up on those biases with a pretty high degree of accuracy.
Which is pretty impressive when you think about it. Like, these cognitive biases, they're often very subtle. They're wrapped up in the nuances of language and context. It's not always easy for even a trained human to spot them reliably.
Right. It's not like we have a bias detector in our brains.
No, definitely not. And that's what makes this work, I think, so significant. It's like we're starting to develop tools that can help us see these biases that we've been, kind of blind to for so long.
It's almost like giving ourselves a new lens to view the world through, one that helps us see things more objectively.
Exactly. And I think to really appreciate the impact of this research, it's helpful to understand the context, the history of how we got to this point. Like, why is this work so timely right now?
Yeah, okay, let's take that step back for a minute. Let's rewind the tape a bit.
So for a long time, the conversation around AI and bias, it was very much focused on the biases that were already present in AI systems themselves.
Yeah.
Like, how do we prevent algorithms from perpetuating existing societal biases? Things like racial bias, gender bias.
Yeah, and I think there were some pretty high-profile cases that really brought this issue to light. Like, I remember that case with Amazon's hiring algorithm.
Oh, yeah, the infamous Amazon hiring algorithm. That was a big wake-up call for a lot of people.
Right. I mean, the algorithm was trained on data from previous hiring decisions. And since those decisions reflected existing gender imbalances, the algorithm ended up, basically discriminating against women.
Exactly. And that was a huge problem because it showed how easily those initial human biases, those biases that are baked into the data we feed these models, can get amplified by the algorithms themselves.
And so that led to a whole bunch of research on how to de-bias these systems, how to make them fairer, how to audit them for bias.
Yeah, absolutely. There was a real push to develop tools and techniques to, make sure that the AI we were building wasn't making the world a less fair place.
And I think that's where we saw the emergence of things like NBias, right? These frameworks that try to automatically detect biased language in text.
Exactly. NBias is a great example of that. It uses these really powerful transformer models to try and flag words and phrases that might be indicative of bias in different contexts.
And then there were also these really interesting approaches that look at how to de-bias human AI collaboration in real time.
Yeah, like imagine you're using an AI-powered writing assistant. These systems would try to nudge you away from, say, anchoring bias, which is where you get fixated on the first piece of information you see, even if it's not the most relevant.
It's like having a little AI bias buster on your shoulder, whispering in your ear, hey, are you sure you're thinking about this objectively?
Exactly. And these approaches, they were all really important steps towards creating more responsible and fairer AI systems. But what's so unique about the paper we're talking about today is that it takes this whole conversation in a new direction.
It's not about fixing the AI. It's about using the AI to help us fix ourselves.
Precisely. And this builds on this really rich history of research in psychology, especially the work of Kahneman and Tversky, who really pioneered the study of cognitive biases.
Oh yeah, Kahneman, the thinking fast and slow guy. I read that book. It's a really interesting exploration of how our brains work and how they can sometimes lead us astray.
Yeah, that's a classic. And their research, along with the work of many others in the field, has really laid the groundwork for understanding these systematic errors in judgment that we all make, these cognitive biases that can really skew our thinking.
And these biases, they're not just some abstract academic concept, right? They have real-world consequences.
Oh, absolutely. The paper actually gives some really compelling examples across various industries.
Yeah, like in healthcare, biases can affect how doctors diagnose patients, which obviously has huge implications.
Right. And in finance, biases can influence investment decisions or even how credit scores are calculated, which can have a significant impact on people's lives.
And then you have the legal field, where judges and lawyers are supposed to be impartial, but biases can creep into their reasoning, affecting the outcome of cases.
Exactly. So you see these cognitive biases, they're everywhere, and they can have real consequences in the real world.
And that's why this paper, I think, is so important, because it's saying, okay, we can use AI to help us become aware of these biases so that we can hopefully make better decisions, communicate more effectively, and create a fairer world.
Exactly. And what I found really interesting is that they didn't just take a generic approach. They didn't just say, okay, let's throw a bunch of data at an LLM and see what happens. They were very deliberate about the specific biases they wanted to target and how they wanted to train the LLM to recognize those biases.
Yeah, let's talk about how they actually did that, because that's the real meat of this research.
Okay, so first, they carefully defined 6 specific cognitive biases: strawman, false causality, circular reasoning, mirror imaging, confirmation bias, and hidden assumptions.
Those are some familiar ones. I think I'm guilty of a few of those myself.
Oh, we all are. The point is they needed to give the LLM very clear targets to look for.
Yeah, that makes sense. Like, you can't just say to the AI, hey, find some bias. You have to be much more specific.
Exactly. So for each of these biases, they broke down the core logical fallacy, the characteristic way that bias distorts thinking. For example, with the strawman argument, you're misrepresenting your opponent's view to make it easier to attack. It's like, setting up a scarecrow and then knocking it down as if you've achieved something.
Yeah, I've seen that happen in online debates.
All the time. Then you have circular reasoning, which is basically where your conclusion is the same as your premise. It's like saying, well, I'm right because I said so, which is not exactly a compelling argument.
Right. No, that doesn't fly.
And then they had confirmation bias, which is, I think, one of the most pervasive biases.
Yeah, confirmation bias is that thing where you only look for information that confirms what you already believe, and you ignore everything else.
Exactly. And you see that playing out, I think, in so many areas of life.
Oh, absolutely. I mean, think about politics, social media, even just everyday conversations. We tend to gravitate towards information that reinforces our existing worldview.
Right. And that can make it really hard to have productive discussions and to, actually change our minds about things.
Okay, so they had their 6 biases. They defined them clearly. What did they do next?
They needed data, like lots and lots of text data to train the LLM on.
Of course. You can't train an AI on thin air.
Right. So they gathered a ton of text from all these different sources: X, Reddit, Medium, academic papers, government websites, you name it.
Wow, that's a lot of reading material.
It was, and they deliberately included content that was both formal and informal, rigorous, and, well, not so rigorous, because they wanted to make sure the LLM could handle different styles of writing.
That's smart, because biases can show up in different ways depending on the context.
Exactly. And they also included content from people with opposing viewpoints, especially on controversial topics.
Oh, so they really threw the LLM into the deep end.
They did. They wanted to make sure the LLM wasn't just picking up on certain keywords or phrases, but was actually understanding the underlying logic of the arguments.
Okay, so lots of data, carefully chosen to represent a real-world mix of content. What was the next step?
Well, they needed a way to process all this data, right?
Yeah, because LLMs, they can only handle so much text at a time.
Right. So they used this toolkit called LangChain, which is pretty popular in the LLM world.
Oh yeah, I've heard of that.
It's like a toolbox for building LLM-powered applications. And LangChain has this really handy feature where it can split large documents into smaller chunks that the LLM can digest.
Okay, so they used LangChain to chop up the text into bite-sized pieces. What then?
Then came the training. And this is where things get really interesting because it's not just about feeding the LLM data, it's about how you feed it the data. It's about the instructions you give it.
Right, and this is where the prompt engineering part of the paper's title comes in.
Exactly. So they developed these very specific structured prompts that were designed to guide the LLM towards recognizing those 6 biases.
Okay, so like what would one of these prompts look like?
Well, let's say they wanted to train the LLM to recognize confirmation bias. The prompt might be something like, given this text, identify any instances where the author selectively focuses on information that confirms their pre-existing beliefs while ignoring or downplaying contradictory evidence.
Okay, so it's not just, hey, is there bias here? It's like giving the LLM a very detailed checklist of what to look for.
Exactly. And the prompts were designed to mimic the actual thought patterns associated with each bias, like those logical fallacies we talked about earlier.
So they're essentially teaching the LLM how to think like a biased human, but in reverse.
Right. It's like, okay, LLM, here's how a human would twist logic to fit their bias. Now go find examples of that in this text.
That's so clever.
Yeah.
And did this careful prompt engineering, did it actually work?
That's the million-dollar question. And the answer is, yeah, it did. In fact, it worked really well.
Okay, tell me about the results.
All right, so first, they tested their prompt-engineered LLM on a large data set of text, and they found that it could detect those 6 biases with an accuracy rate of at least 96%.
96%? That's really impressive.
It is. And they also found that certain biases were easier to detect than others. Like circular reasoning, the LLM had no problem with that. It was getting it right almost every time.
Right, because circular reasoning, it's kind of like a very clear pattern, right? It's easy to spot once you know what you're looking for.
Exactly. But some of the other biases, like false causality, those were a bit trickier.
Yeah, false causality, that's like the classic correlation does not equal causation thing, right?
Exactly. Just because 2 things happen together doesn't mean one caused the other. And that can be really hard to tease apart, even for humans.
So even the LLM, with all its intelligence, was struggling a bit with that one.
Yeah, it's a tough nut to crack. But overall, the results were really promising. And then, to really make sure that it was their prompt engineering that was making the difference, they compared their model to a couple of other models.
Okay, what were those other models?
They took the same LLM, the same Mixtra model, but they didn't give it those specialized prompts.
So it was like the control group.
Exactly. And then they also tested a much bigger LLM, the Llama 3 model, but again, without those carefully crafted prompts.
Interesting. So it was like a size comparison as well?
Right. They wanted to see if just having a bigger, more powerful LLM would be enough to detect those biases effectively.
Oh, what did they find?
Well, what they found was that their prompt-engineered Mixtra model, it actually outperformed both of the other models across all 6 biases.
Really? So even the bigger, fancier Llama 3 model couldn't keep up with the smaller, smarter Mixtral model?
Nope. And that was a really important finding because it showed that it's not just about the raw power of the LLM, it's about how you guide that power, how you ask the right questions.
It's like saying, hey, having a supercomputer is great, but if you don't know how to program it, it's not going to do you much good.
Exactly. It's the instructions that matter, the prompts that tell the LLM what to focus on, how to analyze the text. And that's what this paper really highlights, the power of prompt engineering.
That's a great takeaway. I mean, it has implications way beyond bias detection, right? It suggests that for any task, any problem you're trying to solve with an LLM, carefully designing your prompts is absolutely crucial.
Totally agree. It's not just about throwing data at the model and hoping for the best. It's about being strategic, being thoughtful about how you interact with these powerful tools.
So this paper, it's not just a technical achievement, it's also like a design lesson.
Absolutely. It's a lesson in how to get the most out of these LLMs, how to guide them towards the insights we're looking for.
Now, before we move on to our novel notions segment, where we get to speculate a bit about where this research could lead, I think it's important to point out that the researchers themselves acknowledge some limitations in their work.
Yeah, they're very upfront about that, which is, always a good sign in any research paper.
Okay, so what are some of the caveats here?
Well, one thing they point out is that their study mainly focused on English language text, so it's not clear how well this approach would work for other languages.
Yeah, that makes sense. Languages have different structures, different nuances.
Exactly. And then there's the whole issue of context. Like some biases, they might be really subtle and hard to detect without understanding the broader context of the conversation or the situation.
Right, like sarcasm, for example. It can be really hard to tell if someone is being sarcastic in text, and that can completely change the meaning of what they're saying.
Exactly. And that's something that even the most advanced LLMs still struggle with understanding those really subtle layers of meaning.
And then there's the whole issue of human annotation, right? Like even with careful training, there's always going to be some subjectivity involved when humans are labeling data.
Yeah, that's always a challenge in machine learning, especially when you're dealing with something as complex as cognitive biases.
And the researchers, they're also aware that even though their model outperformed the larger Llama 3 model, there might be even better ways to fine-tune these LLMs specifically for bias detection.
Right, it's an ongoing area of research. There's always room for improvement.
Okay, so lots of promising results, but also some important things to keep in mind as we move forward.
Exactly. It's a really exciting area of research, but we need to be cautious and thoughtful about how we develop and apply these technologies.
Okay, now for the fun part, our novel notions segment, where we put on our speculative hats and imagine where this research could lead, what new avenues it could open up.
All right, I've got a few ideas brewing.
Hit me.
So this paper focused on detecting individual biases, right? But in the real world, biases often work in combination. Like you might have someone who's exhibiting both confirmation bias and the availability heuristic, which is where you overestimate the likelihood of something happening because you can easily recall examples of it.
Yeah, that makes sense. It's like a bias cocktail.
Exactly. So one really interesting direction would be to explore how we could use prompt engineering to detect those combinations of biases. Like, could we design prompts that are specifically looking for patterns that suggest multiple biases are at play?
That's fascinating. And the prompts for that would have to be pretty sophisticated, right?
They would. It would be like teaching the LLM to recognize those really intricate, almost synergistic relationships between different biases.
Okay, I love that. What else?
All right, here's another idea, and this one is maybe a bit more out there.
The wilder, the better.
Okay, so this paper focused on detecting bias, right? But what if we could use AI to actually inoculate people against those biases? Like, what if we could use adversarial prompt engineering to create content that's specifically designed to help people recognize and resist those biases when they encounter them in the real world?
Oh, that's a whole other level. It's like cognitive therapy for bias.
Exactly. It's like building mental antibodies against those biased thought patterns. And we could draw inspiration from psychological inoculation theory, which has shown that exposing people to weakened forms of arguments, like a kind of cognitive vaccine, can actually help them develop resistance to those arguments.
That's amazing. I mean, if it works, the implications for education, for critical thinking, for just how we interact with information, it could be huge.
It could. And I think this ties back to the whole theme of this paper, which is about using AI not just to automate tasks, but to enhance our own cognitive abilities.
To make us better thinkers.
Exactly. It's about empowering people to be more critical, more discerning, more aware of the biases that can shape their thinking.
And of course, we have to be really careful with this kind of approach.
Oh, absolutely. It's important to be super ethical and transparent about how these techniques are developed and used.
Right. We don't want to end up in a world where AI is manipulating people's minds.
Definitely not. The goal is to empower people to think for themselves, not to think for them.
Okay, so those are some really cool novel notions. I'm definitely excited to see where this research goes in the future.
Me too. It's a really fascinating time to be working in this field.
Well, on that note, I think we should wrap up this deep dive. But before we go, if you're listening and you're interested in learning more, you can find the full paper link in the show notes.
Definitely check it out. It's well worth a read.
And one final thought for you to ponder. Now that you know AI can be used to detect these patterns of bias in text, where in your life, in the information you consume, in the way you communicate, where do you think this kind of analysis could be most valuable?
That's a great question for everyone to consider.
Thanks for listening to Talk Tensors. We'll see you next time.